Hey, welcome back, guys. This is Professor Rodan, and I'm here to talk about 6.7 in college algebra. 6.7 is about systems, and by the way, this is the last section of the course. System of inequalities. And so we need to review most of this is review, and so we're going to do a review of just one inequality, and it could be linear or it can be quadratic. So let's get started. This is just the lesson portion, and you do need to watch the videos online, and this is just some extra help for the lesson portion of your assignment. Okay, so first of all, this inequality is linear. This is linear. It's also vertical. Because, why is it vertical? It's because the slope is undefined. So basically, this is going to be at x equals 5. And since it has an equal sign, it's going to be solid. All right, so this so less than or equal to or greater than or equal to, which they both have equal signs under them. Okay, so it's going to include the line or include the graph. So this is going to be a solid line or solid graph, I should say. Okay, so in this case, we're going to do solid, vertical, at x equals 5. Now, the solution of this inequality is also less than 5. So everything, all the x's less than 5 are going to be to the left. So what we're going to do is shade to the left. Okay. Now that is pretty much the only scenario you're going to do left versus right. Okay, which just is pretty much a definition of less than is numbers lesser than 5 or to the left of. But for the most part, everything else you're going to deal with would be up or down or above and below. So let's take a look at a couple more things here just to keep in mind. So if it doesn't have the equal sign, then that's going to be a dashed graph. Okay, so this one's solid, for example, where this one is dashed. Okay, and then usually less than is going to be the shade below. So for example, if we have a quadratic and it's less than, we're going to shade below. If it's greater than, we're going to shade above. Okay? So, let's get started with another inequality. So this is another linear equation or inequality. And we could do, we could solve for y. And if we solve for y, I mean, we could quickly see if it's a greater than or if the y is a less than, so we can shade above or below. But I'm not going to do it this time because I want to show you the test point method, which is it's going to work with, sometimes you cannot solve for y. So that's going to allow us to test some points above or below. So in this case, we can use intercepts to graph. These are really easy to find in this particular case because the coefficients 4 and 5 are both factors of 20. So to find the x-intercept, we make y 0. Well, let me do that down. So if y is 0, then that means it's going to be negative 5x is greater than 20 because the y made that 4 go to 0. And then x is going to be, well, so just remember when you divide by a negative, I'm sorry, we're not supposed to be doing that here. We're just finding intercepts, my bad. So we don't need to, this is negative 4. So we're going to go ahead and plot that over here. And then we're going to find the y-intercept. That's when x is 0. That's going to make the x term disappear, leaving you with 4y equals 20. So divide by 4. Y is going to equal 5. Okay. So now we also know that is dashed. So we're going to go ahead and dash this thing. Okay. Now, since we don't have y by itself, we don't know if it's less than or greater than, but we can do a test point. And the easiest point to test will be 0, 0. If we get a true for our test point 0, 0, then we're going to shade below the line. If we get a false for 0, 0, we're going to shade above the line. Okay, so let's go ahead and plug it in. So 4 times 0 minus 5 times 0. So it's 0 minus 0. So 0 is not greater than 20. This is false. Since it's false, since down the test point is false, that means true would be above the line. All these would be, any of these points up here would make this true, so we're going to shade above the line. Okay, so that's basically it for graphing inequality. So the solution is the solution set that lies above the line, which is is an infinite region above it. Okay, let's take a look at number 3. And number 3 is, as you can see, it's a circle because we have x squared and y squared. So this is a circle. And we know from the circle that we have the center. So the center is HK, so there is no H, that means H is 0. And there's the K, so it's going to be negative 5. Okay, so it's the opposite of the inside there, because the formula has a minus. All right, and we need another minus to make that positive. So then the radius squared is 9, so that means the radius is 3. So we can go ahead and graph this thing. So we're going to do 0, negative 5 with the radius of 3. 3 to the right, 3 above it, 3 to the left, 3 down. Okay, there's my circle. And I did that solid. I forgot to mention that because there's an equal sign. Now, it does say less than. So we need to do a test point. And again, the easiest test point will be 0, 0. So we're going to test 0, 0. So 0 squared plus 0 plus 5 squared is less than or equal to 9. 0 plus 5 squared is 25. 25 is not less than 9, so this is false. So that means outside the circle is false, and that means we shade on the other side of the circle, which should be in here. Okay? So this is how inequalities work with nonlinear functions. Okay, let's do number 4. Number 4 is our first system, okay? So we have a quadratic here, which is a parabola. And we have another quadratic. But really, you could have a mixture of any various types of functions that you've studied in this course. Okay, and it looks like they're both open up because they're positive x squares. Okay, so let's go ahead and graph using transformations. Actually, I'm sorry, this is not right. This one's upside down. So the reason why it's upside down is because y is actually less than or equal to negative x squared. And the other one is already set up correctly. Okay, so let's go ahead and graph the first one, which is an upside down at the vertex is at 0, 0. So we'll just do a nice little sketch here. And they're both solid. Okay, and we know that since y is by itself, we can go ahead and say it's below this graph here. And then we do, so this is shade below because of the less than, and this is greater than the shade above. So let me go ahead and do this one. So parent function is going to go shift down, and this one is like so. It's greater than, so it's going to be this region here. And so now the solution to the system is all the points in this intersecting or overlapping region. So the solution to the system of inequalities is the overlapping region or regions, depending on the functions. So as you can see here, we have, including the graph edges, and then everything that overlaps in this region here. Okay, and there is our solution to the quadratic inequalities. Okay, so number 5, we have a mixture of a linear, which we're going to go ahead and get it in the proper format, which is negative x plus 2. And then we have a quadratic here. just use a different color this time. Okay. So we're going to do 2 on the y-axis. That's the y-intercept. Go down 1 over 1, which is right there. And these are both equal to, so they're both solid. And it says less than, so I'm going to shade below. And then the other one is a quadratic that is shifted down 3 units. As such, and it's going to be shaded above. And then the overlapping region would be all this right here. And it looks like that. Okay. So this is it for the lesson portion. Just setting you up with some of the basic concepts. And so for the final exam, make sure you can basically do numbers 4 and 5, okay? And recognize the correct answer. And it'll be a mixture of 2 different functions, okay, like number 5. Well, that's it for the course, and let me know if you have any questions. Thank you for your attention.